Accepted.
All right, well, greetings everyone. Thanks for joining. This session is Know Your Java, just to be sure. We did have a switching of rooms, so if you are here for Mohammed's talk, you need to go to the opposite side, that's 4B. If you are in here for this talk, you're in the right room. We apologize for the changes, but we try to accommodate as much as we can. So let's get started. So let's talk a little bit about what we're going to do here today, and then we'll get rolling. Keep in mind that this is a 2-hour session. Right about the middle, 1 hour, I'll ask you if you need a break. If you say you want a break, we'll take a break. Otherwise, we'll just continue for the 2 hours and wrap it up. We're going to talk about Java, and I know what you're thinking. You're thinking, wait a second, we've been using Java for so long, don't we all know Java? Well, that's exactly what I was thinking as well. And what I'm going to share with you is things that I'd like to call as stubbing your toes on. It hurts really bad when you stub your toes, but it's very funny to watch it when others do it, right? So that's been my experience. I've stubbed my toes a lot. But I'm also going to show you some examples of not just the mistakes I've made, but mistakes others have made. Especially, I'll show you some errors from the JDK or how they have designed the API. But I want to emphasize one thing before I go into it. My intention in showing those examples definitely is not to insult them in any way. And I always say this, we live in a very unfair world. And the unfairness of the world is that I make a lot more mistakes than the people who write Java. But the difference between them and me is the following. When I make a mistake, exactly 3 people know about it. My wife and my 2 kids. But when they make a mistake, 10 million people know about it. I know it's very unfair, right? So we're going to look at some mistakes they have made. We're going to look at a few other mistakes we all make. I'll talk about a few mistakes I've seen other people make that have communicated with me so we can learn from those experiences. And before we get started, what fun is it just to look at code than to think about what the code is doing? So you will need your smartphones for this. Can you wave that at me if you have your smartphones? We're going to be using that quite a bit in this session. So are you ready? Let's warm up a little bit with a quick little exercise. We're going to have several exercises for you to respond to. Because this is a large room, it doesn't help to yell at each other the answers, even though that can be fun. So you're going to answer the questions on the web, and we'll take a look at your response, and we'll move forward. But of course, before we get to the real question, we want to do a warm-up. So here's your first warm-up question, if you're ready. Point your cameras at this, and take a stab at answering the question in there, and we'll continue in just a couple of seconds. So you should see a question appear on the screen when you point to that URL. And go ahead and respond to it. Don't worry about being right or wrong. It's anonymous, I promise. It will not know who you are when you respond. And I don't really care about whose response it is. I care more about the collective responses. So take the time to respond to it. I'll leave that there for just another second or so that if you have not had a chance to point your cameras at it, just point to that URL. And just it's a warm-up exercise, not the real exercise we want to work on, but make sure that we are all able to connect to it. There's a different URL for each question, so you're going to be just pointing at it and taking a snap of that and visiting that URL. All right, so the first question that you saw, I'm assuming, is how many years of experience with Java you have, right? And so the question was, I think, less than 10 years, less than 20 years, or more than 30 years. So let's take a look at what the response was from this one. So here is the response we got. We got about 273 people, 74 still people responding. And we got about 58% of the people saying they have less than 10 years of Java. About more than 10 years is about 37%, give or take. More than 20 years is that small percentage. And usually there is somebody who says they have more than 30 years. Those are people who write resumes with all false information, right? Java is not 30 years old, and I don't think anybody said 30 in this case, so that's good. Last time I tried this, there were 10 person who said more than 30 years. You know who writes bad resumes, right? So that's good. Thank you for the response. 298 responses so far. Again, if you don't have the URL, you can point to it, and you can respond to it, and that's the URL. And that's what I'm going to be doing. Just show these URLs. You're going to be taking a little quiz of the questions you are seeing, and then we'll compare the notes, and we'll keep moving forward, right? So that's what we're going to be doing. So right there is 299 responses. Great. So I'm going to move forward. Oh, 300. Awesome. So let's go ahead and look at the first exercise. So the first one here is a code example I'm going to show you that can really trip us a little bit. So let's start with the very first example I want to start with here. Well, the first one is, of course, the number of years of experience, so we'll skip that one. Let's go to the real question here. So this one here is showing us a little code snippet. I want you to take a look at this code for just a second. We have numbers equal to new array list of integer, and the left side shows a list, as you can see. And we have printing out the values that should be 1, 2, and 3 being printed. Then I call remove of 1, and we print out the result, and the result should be 1 and 3. There's no surprise, no tricks in there. So if I go back and run that code, you can see in this particular case, actually I should set this properly, so give me a second for me to do that. So if you run that code really quickly here, what you should be able to notice here is 1, 2, 3, and 1 and 3, which is exactly what I said the response will be. The question to you is, if I change the list that's here to collection like so, what's going to be the output, right? So that's the question for you. Fire away at your response, and let's see what you have to say. We got about 300 responses last time. Let's see what percentage of responses get this one. And don't worry about being right or wrong. That's the whole point of this, is it can be a little tricky when you look at these things. So if you have not had a chance to point your cameras at it, please do so, that URL. And I'll switch over in just about a minute. All right, so the question is, we are modifying the list to a collection. What is the answer you would like to hear? It should be the same, right? There should be no difference would be the ideal answer. But what is going to be the answer when we switch this from a list to a collection? Before we answer that question, let's see how we are doing here. So let's go over to exercise 1 right there. We had 295 responses. Those 5 people are still searching for the meaning of life. So now, let's go ahead and take a look at the output. We have 41% say it is 1 and 3. We got about 43% say it is 2 and 4. Something tells me the correctness is not based on democracy, right? I know democracy is a good thing to have, but I don't think the number of votes counts in right or wrong of an answer, right? This also is a bit shocking, isn't it? About half the group thought one answer is right, the other half thought the other answer is right, and then there are people right in between who are thinking other answers as well. And I love the response, I don't know. I think we should give an applause to those people for that courage, right? I love it. I love that. That's the best answer in my opinion. I always get away because the minute I say I don't know, people don't mess with me anymore, right? So that's a good answer. So thank you for that answer. So the question is, what's going to be the output? Now, clearly, this is confusing. Some of us are right. Some of us are struggling to find the answer. So what could be the answer? So let's go ahead and run this code before we see discuss about it. The answer is 2 and 3, as you can see, not 1 and 2. So the output in this particular case, unfortunately, was 2 and 3 rather than 1 and 2. So what went wrong? Now, this is an example of what we shouldn't do. So this is a way to learn about our own design in our code. So when overriding, we should not change the type of the parameters. So this can be really disastrous if we do it. So what they did was originally, in the case of a collection and a list, they really had a remove object, and they had a function that would remove an object. Now, along the way, unfortunately, they decided to introduce a function called remove@index. This is also known as bad idea. So the problem with this approach is now you have two functions overloading each other, where this function that's overloading is really going to mess up in very edge cases, rare situations. When you're using an integer could be boxed to an object of integer, big I integer, or it could be used as an index itself. The right solution here, this is something for us to learn from, right? The right solution would have been remove@index. If they had called it as remove@index, there wouldn't be any confusion at all. It would be very clear to see, even as a reader, you clearly know what's removing. Are you removing an object, or are you removing at an index, right? That becomes very clear. So this is something for us to really learn from. When we design our own code, when we design our own API, naming is always a problem. But this is one of the reasons why I always have somebody else take a look at the code I'm writing. I learned very early on in my life that I have a superpower. And I think a lot of people in this room also share the same superpower that I have. And I quickly realized that I write terrible code. I'll be absolutely honest about it. If you ever look at my code, you'll be in a state of shock. You would say, oh my gosh, you speak so many conferences, you give so many talks, that's the code you write? Well, absolutely, I write really, really horrible code. But what I realized over time is I'm extremely good in finding fault with other people's code. So that is my superpower. So I realized rather than pretending I can write really good code, I write code I can write, but I start complaining about other people's code while they complain about my code. So we both can improve the code immediately. This is one of the things I like to do all the time is I go to somebody else in my team and say, can you take a look at the code? And they critique my code, they tell me better names for functions, and then we improve on it. So that can be a way to catch these kinds of errors. So we want to be a little careful about it. So the answer to this question turns out to be a 2 and a 3, as you can see in there. And looking at this, 2 and 3, we can see 44% got it right. That's a good news, but trailing pretty close, 41% is the one that we got. We got the other right answer, I would say, what it should be rather than what it actually is. So that's really the between one. And so you can see the difference in the code, so something for us to learn from. So the moral of the story is be extremely careful when you're overriding and overloading, and it always makes a big difference to give good names for variables, good names for functions. In this case, remove@index would have been a better name than remove itself. Now, somewhat related to that, but not entirely the same code, we'll take a look at that in the next example here. So we'll come to that in just a minute. But this is about type inference. But before I go further, I want to really emphasize I love type inference. Now, a lot of developers who use Java have a mixed opinion about it. Some people love it, some people hate it. Well, this reminds me of an experience. A few years ago, I give a talk in user groups oftentimes, and I wanted to go give a talk in the Dallas Java user group. And months ahead, they said, what do you want to talk about? Without thinking, I said, I'll talk about type inference. Well, the night before the user group meeting, I was looking up on the web. What am I going to talk about tomorrow is when I realized I've got a new talk on type inference. I was in a bit of a panic because I can spend exactly 10 seconds talking about type inference. Java has type inference. Thanks for coming for my talk. So what can I do for 90 minutes on a topic of type inference? the talk did not go for 90 minutes. It went for 120 minutes. And the people in the room were split halfway. The right side loved type inference, the left side hated it. And there was a fight going to break out at 9:30 in the evening. So we were kind of really scared for the safety of people at that point. Remember, it's the middle of Texas. So the point really is, people either love it or people actually hate it. But I actually belong to the camp of loving it because I find that type inference reduces the noise in the code. But of course, type information is useful, but we can use IDEs to look at type oftentimes. So I'm in all prices of type inference all the time. Except there are times when we could get into trouble using type inference as well. So let's take a look at one quick example here. So as you can see in this example, we have a collection of numbers, as you can see. And when I run this code, the output goes from 1, 2, 3 to a 2, 3, as you can see right there. So the question for us is, if you change the collection of integer to a var, what's going to happen to the output, right? That's the question. So changing collection to a var, what's going to happen? So here you go. Take a stab at it, and let's see what the difference is going to be in the code. So let's see what you have to say about this code. I like the sinister laughter over there, right? That's nice. Yeah, feel free to discuss, make noise. That's what here we are for. Absolutely. All right. Should we look at the solution? Would you like a chair to the front? Come on over. That's a first-class seat here. All right. Let's take a look at the response for this. This is the question 2, exercise 2. So let's take a look. Oop, right there is exercise 2 as we can bring it. So we had 315 responses. Great. Somehow 15 more people showed up. The 71% says 1 and 3. 15% of us say 2 and 3. A small percentage of people say 1 and 2. And 12% gave a beautiful answer, my stomach hurts. I like that response again. So what is the answer, right? So is the 70% correct in this response? So if we go back and run the code, you can see that the 70% got it right. So essentially what happened here is kudos for that. But the rest of us, I'm as confused as anybody else is when you look at it. What actually happened in this case is that numbers was collection of integer, but now is an array, a list of integer. So we have to be very careful when we use type inference. Is it really the type that we want it to be? So when you are using type inference, like I said, I'm a huge fan of type inference. I like using it, but you want to really make sure the type it infers is the type you think it should be. Now, remember one thing. They always say this. If you disagree with the compiler, you know who's going to win. So always, right? So it's not about your opinion. It's not about what you like and what you dislike. I respect people's opinion, but I never disagree with what a compiler says, right? Compiler always wins. So we have to understand what does the compiler infer the type to be. So this is one of the things to be careful about. Type inference is useful when you're assigning the variable to a return value of a function. That's a great idea. So if you say var whatever that you are receiving is equal to some, function. You could say a function that does some, work. So this is a good idea because the type here is determined based on the return type of the function. But if you use type inference in a case like this one, you are having to be going to trouble because even though your interface is the real intended type, your type is going to end up being a concrete type, not a type of an interface, and so there could be consequences to that. In ideal situation, you shouldn't have these problems. As we can all agree, there was a poorly written function. So we could say, okay, so what's the big deal? The big deal really is, ignoring that kind of problems you may have, if you're using an interface, the functions you are calling can only be part of the interface. If it is a class, the functions you are calling could be part of the class, which are not part of the interface. So if you really want to restrict yourselves to calling the functions in an interface and not a class, you may not want to use type inference at that point. So your mileage may vary. So as much as I love type inference, my recommendation is pay close attention to what the type is. It may not really be the type you really intend to be, and you want to be sure that you're using the right type in the code in general. Great. So we answered that really nicely. Good job on that one. The next question here is something about a mistake I made. So in a previous version of functional programming in Java I made an erroneous call. I said that AsList creates an immutable collection. And I love getting email from people. And this one email was from somebody who read the book and said, well, you're wrong. And you said this is immutable, and it is not. This is a little bit more embarrassing because more than 3 people know about it. This also showed me that there was actually one person who read my book, which is amazing. So this person said, I read your book, but you're wrong. Now, of course, this is why you write second edition of the books. So you can fix the errors and create new ones, right? So I'll find out what new errors I introduced in the second edition, but that came about. But I want to share that with you in the next exercise here. So let's go ahead and take a look at the next piece of code. So what I have here is a list of integer equal to numbers is equal to arrays of AsList. So we got an AsList that creates 1, 2, and 3. Then we call add, and we add a 4 to it. If that succeeded, the 4 would be added. If it failed at runtime, it would tell us add unsupported. Then I do a set on it with a 2 and a 2, meaning set the value at location 2 to a value 2. If that worked, it moves on. If it failed, it'll say set unsupported. And then we print the numbers in the end. So the question to you is, in the next one, what's going to be the output of that code? So fire away, and let's take a look at it. Maybe we should play some music while you're trying to take it. I still see a few cameras up in the air, so I'll wait for you to take a snap of that URL. I think all hands are down, so it's good time to visit the response. So this is question 3. All ready? All right. So this is 3. So I love this, right? Now you know why democracy is in such a bad shape. Okay. So 32% said add unsupported. 25% said set unsupported. 32% said add unsupported, set unsupported. And, well, actually, I apologize. 32% said 1, 2, 2, 4. and 10% said add unsupported, set unsupported. Now, so 32% said add unsupported, right? That's good news. So at least among the responses, majority actually wins in this case as well. Let's take a look at the response in this case before we move forward. So run the code. It says add unsupported, and then 1, 2, and 2. So let's take a look at the reason for that. Well, here is the problem with as-list. As-list does not create an immutable collection. That's my misunderstanding. It collects a array-backed list, and as a result, you cannot expand the size of the array. So add is not supported. Unfortunately, you can set into it. That's why you can see the value is 1, 2, and 2, because this operation actually succeeded. So what is the moral of the story? The moral of the story is quit using as-list. This is not a good idea because it confused the heck out of me, so that should be banned from its use, right? So don't use as-list. If you are using Java 9 or later, and I'm hoping that you are in more recent versions of Java, a beautiful function is the function called listof, and similarly a setof and mapof are all my favorite functions. I really like the listof function. So let's spend just a couple of minutes, instead I would argue in this case, so instead use listof. So let's take a look at this a little bit and play with it just for a few minutes. So if you look at this particular example, as you can see, we are using the as-list, which did not help us a great deal. But let's go ahead and output over here numbers dot, let's say, get class, and take a look at the class of that particular object. So you can see it's a array list with a $array list. But if you look at the output, add not supported, as you can see, but it gave us a 1, 2, and a 3. But if I change that instead to a more modern version, and if I were to say a list of, in this case, so notice what the output is going to be. The output says it's an immutable collections $list n. So it actually gives you an immutable collection, and you can see it is both add unsupported and also set unsupported, because you cannot add to it, you cannot set into it also. So my recommendation is, moving forward, if you are going to touch a piece of code and you see that it's using as-list, take just a couple of minutes to refactor that code and use a listof, because that gives you a much better immutable version, and that is my preference these days, is use listof and things like setof and mapof. When you're using as-list, instead use listof. That's much a better option in general. So don't go for that as much as you can. So far, so good. Now, the next question I'm going to show you here is something. Let me just look at it before I say that. Oh, yeah. So before we talk about it, now, I get emails almost every week, if not a few emails, and I love getting emails from people. But this one email I got from a developer. I cannot tell the company this person works for, but I can tell you that millions and millions of people in the world have their pension plan with this company. So our money is with them. And this programmer wrote me an email, and the email started with the following question. Hey, Venkat, I've got a piece of code shown below. It worked fine until yesterday. And this morning, all hell broke loose. Can you tell me what is wrong with this code? Well, thankfully, I didn't have to take a lot of time to read the code. I quickly kind of, when you start reading emails, the back of your hair and the back of your neck kind of stands up because you kind of know what's coming. And so I quickly look at the code, and right there, I found the problem right away. But the code example I'm going to show you is a great simplification of this. But what this person actually had was a customer, and the code went and pulled all the funds the customer had. And when the code pulled all the funds the customer had, they performed a transformation of the data and filtering, and then they put back the result into a collection. Now, I often say that the following. People often talk about, we know this famous phrase that we often use, right? And the famous phrase is called works on my machine, right? I would challenge you, I don't want works on my machine. I want fails on my machine. Because here's the lesson I learned. If you are very lucky, the code fails on your machine. If not, of course, it fails in production. So I would rather fail on my machine. This programmer I talked about was extremely lucky because he ran the code on his machine. What a concept, right? He didn't compile it and say ship it. He actually tried to test it, and it didn't work on his machine. And so he said, gosh, this is not working properly. Let me find out. If he was not that lucky, guess what could have happened? He would have committed the code, and he wouldn't have known what happened. And of course, I call these in code is the ticking time bombs. So essentially, we got quite a few of these. The reason is the person who is writing the code will not get this error. They may actually quit. And 6 months after they quit, your phone rings at 2 a.m. on that Wednesday. And your boss is grumpy and says, your code sucks, comes to work. And you're like, what? And you look at the code that is failing, and you say, I didn't even write it. And the boss says, I don't care. You attend to the call, it's your problem now, right? So you have to go fix the mess. And this is called, the person who gets called in the middle of the night, they're not programmers or software engineers. They are the victims, right? So you are victimized by somebody else's code that somebody wrote. So let's take a look at this code and see why this could be a problem, right? So, and I've seen code like this, but before I go into it, I'm going to ask you a question as well. So notice what we have in this particular code. I have a collection of names, as you can see right there. And how many names do I have? 1, 2, 3, 4, 5, 6, 7 names. So then I have an array list I created. I go through a stream. I modify the names to uppercase, and in the for each function, I am taking the name, which is an uppercase, and I put that back into the add function. And then I print the size of the original collection and the size of the result collection as well. So when I run the code, you can see the result is 7 and 7, right? So my question to you is, what could be wrong in this code? What is a ticking time bomb in this code? So let's take a look. Oop, don't get angry about it. I hear the laughter. There's only two options. You can either cry or you can laugh. I'm glad you chose the latter. I see a few more cameras up still, so I'll give it just a second. All right, I think all cameras are down. Before I look at the response, I want to ask you a question. Raise your hand if you have ever seen code like this in your own applications, where people have added things to the for each. Hands go up, right? I have told people countless number of times, don't do this, don't do this, don't do this. I cannot tell you how many times I come across code like this. Every week, I'm working on a client code, I'm doing reviews of code, and I tell them don't do it. And I have to be absolutely honest with you. And I've told people so many times, never, never, never do this. And I recently was looking at a piece of code that only I have access to. I am the only person who has written this code. And I'm looking at the code, and right in the middle is a for each where I'm changing a variable. And I'm like, are you serious now? And I'm like, as if I have to talk to myself, like, don't do this. Of course, I would admit this to you. I left the window open in the night. Who knows, an alien could have come and modified that code, right? But I know not to do it, and yet I have done it. So what could be wrong with the code like this? This is exercise 4, so let's take a look at the responses before we go further. So the first response, nothing, it's beautiful the way God created, right? And 33% think that it's the most beautiful code. I challenge you to frame it and put it on the wall, right? And worship it daily. It's absolutely beautiful. The next response, 47% said, the lambda passed to for each has side effects. So that's the second response, 47%. The third response, 13% says the lambda passed to for each should be a method reference. I love that response because that solves no problem in the world, right? So this is great. So sometimes we want to really make things a little better. I did refactor the code, right? So that's awesome. And the last response, blue color says, actually the green color says, actually I read the numbers wrong. The green color says, I have a bad feeling. I like the bad feeling, right? The 33%. I don't know what's wrong, but I think something is wrong. Something is sinistrous about it, right? Well, great. So you guys are doing really well. So when you look at this code, what is the wrong with it? This is a bad idea. So why is it a bad idea? Because this is doing a shared mutability is devil's work. So this is really a bad thing to do. We should definitely avoid it. Now you may run this code and say, but it works, right? Well, works is a terrible word. Now let's go back to the example that I talked about. So what does this programmer do, unfortunately? The programmer who emailed me said, this code worked fine until yesterday and all hell broke loose this morning. So what this person did that morning is change this to a parallel stream. And that's all the person did. And what could possibly go wrong? Now, when I run the code, the result is 7 and 7. This is one of the beautiful things. I no longer say the code works. That's a really tall order. I say the code behaves. That's all I can say, right? It's behaving. It's doing something. And it's like a child. Sometimes the behavior is good, sometimes it's not really good. So you may say, what's really wrong with this, Venkat? It seems like it's working, right? So let's go ahead and say, run Java, and I'm going to just run that on the command line and see what actually happens. So that particular script needs Java 21, so I'll change it to that. So I'm going to just change that really quickly and run it, 7 and 7, right? So this is one of the things you have to be very careful about. You have a code that is suddenly misbehaving. You're looking at the output, you're looking at the error, you cannot understand, you cannot reason. So you call a colleague and say, hey, this is broken, can you please take a look at it? And your colleague says, everything seems fine, and you're not able to show anything. And they walk away, and suddenly your code is misbehaving. How do you reason with the code like that? And you say, gosh, it broke again, and they're like, I cannot reproduce this problem. Now, I may not be able to reproduce this also. There's no guarantees that I can show you this, because I could be running this for a long time, and I may never see a problem, so I cannot really guarantee. I'll try this a few times, otherwise I will let you play with it later on, because there are times I would be running this for a long time, it would never show a difference, and all of a sudden, it might show me a difference, who knows, so I cannot really prove that to you by running it many times. But there are times when I will be running this, and suddenly the result will be a 7 and a 5, or a 7 and a 6. And how do you reason with some of those things? Well, as it turns out, when multiple threads are running, you have a shared mutable variable, which is the collection. And two threads may be coming in at the same time, and they both are trying to insert into the same variable, into the same list at the same time. And as a result, one of them may get lost. Like I said, I'm running it many times here, and I cannot prove to you it's wrong. And there are times when I would see the result. There are times I cannot show you. So I apologize. The demo gods don't want to be with me today. It's not going to show me a difference. But you may be running this and you may see a difference, right? So if you're so curious, run that for several hours and see if it produces a different result on your side. And I'll just run one more time, and then I'll move on after that. I cannot prove the incorrectness in front of you in that case, but you just have to take my... There we go. It just requires your surrender, right? It's like you bow to the demo god and say, I'm sorry, I will sacrifice the goat tonight for you. And it's like, okay, there you go. So you saw the glimpse of that right there, isn't it? Who wants that kind of problems on their hands, right? So the code fails in production, and your customers lost their account. Who wants to be able to debug that code, right? So the moral of the story is, don't dare write code like that. So if and a lot of us raised our hand earlier. What does that mean? You are sitting on a ticking time bomb. And whoever wrote that code is happily living somewhere else. But you are responsible for that code. Unless you plan to quit today, that is still your problem, right? Because you don't know when that code is going to fail. You don't know how that code is going to fail. And that is pretty scary as it is. And I assume that you agree why that's such a bad idea. So that is why the moral of the story is make sure lambdas are pure. Now, somebody asked me the question, can I make that collection a concurrent collection so that there is thread safety? That is a terrible idea. You don't want to do that because your goal shouldn't be to make that collection concurrent. Your goal should be to use functions that are thread safe. In fact, in this case, it is so much easier to fix it. We'll come to that in just a minute. Make sure lambdas are pure. Do not mutate a shared variable from within the functional pipeline. This is a bad idea. So many people do this, and they are very negligent of it. Me included. I want to emphasize it, right? Because I've written code like this as well, but this is why I rely on code reviews. I cannot be perfect because I may not think through it when I'm writing the code, but when I review somebody's code, I catch that, even though I may write it myself, not realizing when I'm writing the code. So one of the reasons I review code is to make sure these things don't happen, because this can be really dangerous if we do. So what's the moral of the story in this case? Make sure that you're using things that provide thread safety. In this example, though, as it turns out, it's a very simple solution to solve the problem. All you have to do is simply call toList on it directly, and that gives you the list, and you can just simply put that list in there. You don't need that silly temporary variable and a value, and you can just stick into it. So toList is thread safe, and so are a lot of other functions. So avoid mutating objects within your functional pipeline. This is a difference between can I and should I. Can I mutate? Yes. Should I mutate? Heck no, right? So don't mutate. That's a really bad idea. So I've seen a lot of code like that. Anytime I work with a client, I'm doing code reviews. This is top of the line problem I keep pointing to people because this is such a common problem. So if there's one refactoring you can do to your functional style code is to eliminate those mutations in the functional pipeline and remove those, the future you will be thanking you a lot because you are fixing those problems that could erupt later on, like this person did. He was extremely lucky getting this problem during development, but imagine he couldn't get that problem. Like I showed you the example, it could run seemingly just fine for a long time until it blows up once in a while, and it's very, very difficult to track this and find where the problem is. So avoid such mutations. Keep the functional pipeline pure. You'll be really thankful that you actually did. So time to move on to the next one. This is a little bit more about streams. We all have used streams quite a bit, I'm sure. So let's take a look at this code and see what it tells us. So I have this code. Oh, before we go into this code, let me come back to this in just a few minutes, if you would permit me to do so. Let me go to just a little example using Kotlin, because it's more fun to do that. So let's go over here. Let's go ahead and blow away all these. Let's edit a sample.kts. So here is numbers is equal to list of, let's say, 1, 2, and 3. So I'm going to start with a list of 1, 2, and 3 in this particular case. And I'm going to say let's say a val temp is equal to, and I'm going to say numbers.map, and given an element times factor. So I'm going to multiply that. So I say factor equal to 2. Let's start with that. Then I'm going to say temp.for each. And let's go ahead and say, given an element, I just want to print that element out. So not a complicated code, as you can see. So this code is simply iterating, and it wants to print the results for us in this case. This is Kotlin, so let's go ahead and use a list of in this particular case. So this is what happens, by the way, when you use multiple languages. You are not good in any one of them. So this is the problem I face oftentimes is I like to program in multiple languages, but I'm not good in any one of them, as you can see. So let's go ahead and try this one more time. So let's go ahead and run this code and see what it provides for us. So you can see the result of this code is 2, 4, and 6. So far, so good, right? So now I say factor equal to 0. So I'm going to give you 3 options for this particular code. And I want you to choose from one of the 3. So the first option, the result is going to be 0, 0, 0. Second option, result is going to be 2, 4, and 6. And a third option is, I have no clue, I want to go home. So I'll give you 3 responses. So raise your hand if your response is 1, where the values are 0. So you can see the people raising the hand. Thank you for that. Raise your hand if your response is 2, 2, 4, and 6. Great. And raise your hand if your response is option 3. That is the option I like to give. I like to give this question in interviews. And if they try to answer, they are fired already. The response I want from them is, are you stupid? I'm like, you're hired. Because when people write code in my team, I want them to write code that is obvious. The worst code anyone can write is puzzlers. Because then we are solving puzzles, not writing production code. So in this particular code, the question is, what is the response? And the answer is pretty tricky, by the way. We'll come back to this in just a few minutes, if you will. So let's go over to, in this case, let's go over to the Java code, and then we'll come back to this one after this. So here's the Java code. So you have the int factor as a square bracket is equal to int 2, and then we have list of 1, 2, and 3, and we have a stream right there. And numbers is number times factor 0, and then factor 0 is set to 0, and then we print out the results of that particular stream. So what is the output of that code is the question. So let's give it a try. Now that we have seen this code in 2 different languages, right? In Kotlin, and we have seen it in Java as well. I still see a few cameras up. I'll just give it a minute. Yeah, feel free to discuss. That's what we are here for. Don't hesitate. We are perfectly okay to make noise in this room. All right, I think all the cameras are down. Time for us to look at this. This is exercise 5. So let's take a look at exercise 5. So we had 283 responses. we have 64% say 0, 0, 0, 28% say 2, 4, and 6, a small percentage of us, which is 10% who say 1, 2, and 3, and in my opinion, the right answer is 4% who said, I want to go home. So this can be a bit confusing, isn't it? So the answer to this question depends on the language, unfortunately, but more so depends on the semantics. So I'm going to run the Java code in just a minute, but I want to go back to the Kotlin code for a minute before that, just to illustrate the point. So let's go back to the sample.kts. So when I run the code in the case of Kotlin, you can see the result of this code is 2, 4, and 6, which is a little shocking. Why? Because if you take this code in Kotlin, and if you modify this as sequence, and then you run the same code, I just made one small change, and you can see the difference is 0, 0, 0. So Kotlin is one of those languages. Let's talk about it. Kotlin gives you an option to run the, let's say, the functional pipeline, eagerly, or lazily. So you can do either one of them. Java always runs the pipeline lazily. JavaScript, forget about it. So, so essentially, the point really is, so JavaScript runs it always eagerly, but that's not their problem, right? There's other problems to deal with. But the point really is that you need to understand the semantics of what you are working with. So in the case of Kotlin, you can choose eagerness, which is the default, or you can choose laziness. In the case of Java and C# and Python and Haskell and Erlang and a lot of languages, lazy is the option, default. There's no option. That's the only way it works. Language like Ruby, for example, and JavaScript runs them eagerly. So if you're programming in multiple languages, you got to understand the semantical differences. More important, because the syntax doesn't reveal the details, it's in the semantics of the language. So in the case of Kotlin, the answer depends on how you run that code. So as you can see in this particular case, if you run that as a eager evaluation, the result is a 2, 4, and a 6. On the other hand, if you run that as a lazy evaluation, as you can see in this case, the result is a 0, 0, 0. So that is basically the behavior or the difference in the behavior. In the similar note, in the case of Java, when you run it, it is 0, 0, 0. As you rightly pointed out in here, 64% got that right. But the question is, how many of us work with the other 46% of the people? That is almost all of us, right? So if you ask me to maintain that code, I'm going to be very confused because I work in multiple languages. I got to think about the semantical differences. That is cognitive load. And when I'm tired, when I'm working late in the night, I'm going to make mistakes. So this is not a type of mistake you want to really make. So the moral of the story is, please don't do this. Once again, keep the functions very pure. You say, wait. You said keep the functions pure. Yes. So I want to take a few minutes and talk about keep the functions, keep the lambda functions, right? Lambda functions pure. So I want to talk about this a little bit. So the question is, what is a pure function? And I'm going to say a pure function does not have any side effects. But I'm not happy with that definition. A pure function, I would say, a pure function is idempotent. So no matter how many times you call that function, it'll give you the same exact response every single time for the same input. But in order to nail this down, I want to talk about 2 rules for pure functions. And I bet you most of the people you talk to will clearly know rule number 1. And many people don't think of rule number 2. And I'm going to say rule 2 is as important, if not more important, as rule number 1. So this is why it's important to be careful about purity of functions. If you look at the previous example we saw, what did we do in the previous example? In the for each, if you remember, we mutated a shared variable, right? And you look at this and say, yeah, that was not a pure function. But you look at this code and say, that's innocent. It is not mutating anything, right? But I would argue this is not a pure function. Why? So the 2 rules of purity I want to mention here. Rule number 1. First is the function does not modify anything that is where, in a way, the change is visible outside. I know that sounds like a lawyer's talk, right? But I want to really nail it down. I'm not saying don't change anything. No, that's not what I'm saying. Don't change anything in a way the change is visible outside. I'm going to ask you a stupid question. I can ask you, I look at this room and I'm very happy to see the people who are all very nicely dressed. That's a good thing, right? We are all professional. Everybody has shirts and pants. Nobody's indecent in this room. I thank you for that. But if I ask you, did you put your shirt on first this morning, or did you put your pants on first this morning? The right answer is, that's none of your business, right? Some of us in the room put the shirt on first. It's okay, I'm your friends too. Some of us in this room put your pants on first. That's okay too. I don't think anyone here says, I program with concurrency, I put them together at the same time. I don't think that happens, right? So it doesn't matter whether you put the shirt on first or pant on first. The good news is nobody will know about it. You cannot look at the person next to you and say, I know this person is the shirt on first function or a pants on first function, right? No, you're not going to know that. But as long as nobody sees you change, it doesn't matter. Mutate all you want as long as nobody knows that you mutated. That is the whole idea. So it's not that you shouldn't mutate. Nobody should know that you mutated it. So don't make your mutations visible. That's purity. But rule number 2 is more important in my opinion. The function does not depend on anything that may change from the outside. This is something we don't often think about but can hurt us. In this example, you saw 2 examples. The previous example was a violation of rule 1. This example is a violation of rule 2. And both lead to impurity of functions. So for a function to be pure, do no evil, see no evil, right? Both of those are really important. So don't mutate stuff so the mutation is visible outside, and don't rely on anything that is being mutated from the outside either. So both of those are really important for us to keep in mind. So the problem in this code really is that even though the function is not mutating anything, it is relying on something outside that is being mutated, and you don't want to do that. So that's what makes this function impure. In a purely functional programming language, you will not be able to do this. The compiler would not allow you to do. But in hybrid languages, you may be tempted, but it's quite dangerous. So my recommendation is follow the 2 rules of purity. So that is something important for us to keep in mind. So that brings us to the end of exercise 5. We're ready to jump on to exercise 6. Quick question, are you having fun? Cool, thank you. Would you want a break or should we continue? Continue, all right, let's do that. Raise your hand if you want a break. Well, okay, a few hands. All right, how about a 5 minutes break then? Let's do a 5 minutes break and we'll continue. Thank you, I respect that. 5 minutes break. Thank you.